Cool. All right, it looks
Okay, my screen should be shared now, and you should be able to swap to it if.
everything
Ooh.
looks like we're live. Let me go to the YouTube just to make sure, because everything should still have been connected from the last time we did this. Gonna get a bunch of surprised viewers like, "Oh my gosh, what are you doing here?" It's gonna be only John in the chat because he got like a notification about it. Channel. Yes. Okay. So officially we are live. I see it. Oops. Cool. I mean, we'll just jump in like we normally do. Oh, yeah,
It's
see,
been a
there
while
he
since
is.
we've
Oh,
normally
William.
done
There
this.
is John.
And William too. Cool. Oh, awesome. Welcome everybody to it's been quite a while since we've done a live stream. Welcome to another episode of the I guess Puget Systems podcast live edition. This time we're going over the Intel Core 14th Gen processor content creation review, our big roundup of all of the data we've collected for this last product launch. Welcome everyone. David, thank you. William, John, everybody, thanks for showing up. The super impromptu, we didn't advertise this or anything like that. So that's what we're here for. If you guys also, if anybody in the chat has any questions or anything, feel free to ask them in the chat. I'll get to them as they come in, as we have time. So I guess just broad strokes, guys, how do you feel about the Intel 14th Gen? Kelly?
So, Skylar, you want to start?
I would say, like, they're good. There's nothing wrong with them. They're just not much of a change from the previous generation. So that's the biggest takeaway from my stuff, at least, is that like they work great, but they don't work much better than anything else.
Yeah, in a lot of ways, like it. We always get this like refresh. Like every other generation from Intel is typically a refresh. But even those usually give us a 5-10% performance bump. This one, I don't know. It's not even really 14th gen. I'd call it like 13 and a half gen. In a lot of ways, like it's basically they bend them up. So like what was the 13900KS is now basically the 14900K.
Okay.
And then they did do a few small things. The 14700K got more E-cores, so it'll be a little bit better for really heavily threaded stuff, which you don't usually do much with these CPUs. Yeah, and even then, it's not a massive amount. It's like the math. I forget what the math is, but the math is like, yeah, it'll give you up to a 8% performance bump at most. And then the 14600K got just some frequency bumps, but that one is probably the most interesting one, I think, because Kelly, I'm not sure about all of your stuff, but like in the media and entertainment, like video and photo, it ended up having a decent performance gain versus the 13600K.
Yeah. Cool.
So for the people that are on like tight budgets, that like i5 level is actually pretty decent. I don't know why. Like it didn't have anything more than the 14900K as far as like frequency bumps. There's no more cores, no more anything else, no more cache. But it's just a little bit better. So that's
cool. The 14.6 from my stuff had about as much of an improvement as the 14.7 did, even though the 14.7 got extra cores and the 14.6 did not. So yeah, it was. And on the lower end, Intel already had a pretty decisive lead over AMD for that price range. So it's even better now for the budget conscious people.
That's interesting to see that at the lower end, there was better improvement. That's odd.
My guess is some of that is like it's just being bend higher, and they're already pushing the 13.9 so hard that like there's just not much room to improve there.
Oh.
Yeah, well, one of the hard things with CPUs these days is most of the specs don't matter, which is funny to think. But like base clock hasn't mattered for a long time. Turbo kind of matters, sort of, but like that's only if you're operating it at the Intel specified like power limits and thermal limits, which a lot of motherboards totally break and they just do whatever. So some of that is like a caveat here for like, hey, we do our testing following a lot of those things, which means limiting the P1 and or PL1 and PL2 and the tau and all these like little settings that determine how much power the CPU sucks up. We tend to follow the guidelines more strictly than like, you know, a J2Sense or Tom's Hardware or an Antec, who they're looking at like what's the maximum. So maybe they showed a little bit difference than we did, but since we're following all those things and all of those settings are technically the same versus 13th gen, there's only so much you can do. But the 14600K, it has a lot of the same power limits as even those higher end CPUs for like some of the turbo boost stuff. So if it's able to boost longer and it's not like throttling because of power, you know, maybe it's a little bit better on thermals, maybe it's a little bit better on just like what it can maintain for longer for other stuff. Because yeah, power, thermals, and there's a third one. It's mostly power and thermals though is what limits your turbo boosts. But I mean, there's dozens of different things if you start diving into the white papers.
Niche. That has come up a few times in that I've seen on social. And it seems to go back and forth, but right now Intel seems to be getting kind of hit hard with their thermal issue, or not issues. I don't want to say issues because like I haven't really seen anything really definitive that says, oh man, these things run wicked hot. But it seems very anecdotal, at least from what I've seen.
It's on both sides. AMD is kind of the same way, where like they've both kind of increased what thermal limit is and what is okay to hit. And now, like, according to them, 90 degrees is normal. And like for generations, that's been bad. So
yeah, it's just things have changed. You know, we hit this with GPUs, I feel like 5 years ago or something like that. And now a GPU running at 90 Celsius, we say, whatever, who cares? Like, who cares what the temperature is? What are the fan speeds? Sure. Because, like, you know, that'll tell you how close you are to throttling. Like, if you're at 90 Celsius and 50% fan speed, cool, the GPU is throttling correctly, like it's getting you as much performance as possible, and like NVIDIA and AMD say that it'll have good longevity, and that's been happening long enough that we're used to it now, and we do believe that 90 Celsius is not a bad thing on a GPU as long as you've got that cooling headroom. But for some reason, CPU side hasn't really caught up. I don't know if it's because on CPUs you have control over your own cooling, and so people are seeing those numbers and then also seeing like, hey, well, if I use a 3x140 all-in-one liquid cooler, I can get that down to 70 degrees and then cool. So like, no, 90 degrees isn't okay because it's possible to get down to 70.
Sure.
But in reality, like we did a whole article on power draw and cooling.
That's right.
I don't know if you want to switch to it or not. But basically, we looked at we use our normal Noctua cooler that we always use on like all of our systems, and then we looked at a triple by 120, I believe it was, all in one. And we wanted to look at two things. We wanted to see does using the different cooler impact performance at all? So like, does the throttling points change? And two, how does that impact what we can do as far as the power limits? Because a lot of our systems, people would say we're very conservative on the power limits. We're following basically Intel spec, but people would say we're conservative because most motherboards just like unlock everything. That's basically, draw as much power as you want. Like it'll just throttle eventually based on temperatures and other stuff, but like draw as much power as you want. We limit it to the official guidelines.
Right.
And it's interesting what it does for performance. So like, I mean, all of these bars are with the two different power combinations, basically kind of unlimited power, not quite, but kind of, and then like locked to Intel guidelines, and then with the two different coolers. And it's basically, no difference. No difference. A little bit of difference for like Unreal Engine, like heavily threaded stuff, bit more of a difference on very heavily threaded stuff like Cinebench. And that's basically the TLDR there is a beefy cooler and unlocked power limits can help performance sometimes by a decent amount. 10, I think the highest we saw was like 20. What was Cinebench? 14. No, 18% there. So like, it can improve performance by 18%, but you have to keep in mind what those workloads are. How many people are doing, basically Cinebench or Blender, CPU-based rendering, and like that is the bottleneck on their system. Not many. You know, we sell a few systems for that probably, but
Right.
most of those people, if they're really concerned about that, they're going to be jumping up to something like Threadripper Pro, because if it's in a pro space and like your time is money, your render time is money, it pays for itself fairly quickly. You're not going to be sitting on a 14th gen because saying like, hey, this will save me $1,000 on the system. No, whatever. Who cares? That pays for itself in like a month. So in those pro space, and it's very different on consumer. And I think that's one of the hard things is like, you know, AnandTech, Tom's Hardware, Reddit, they are very consumer focused, or like
Right.
enthusiast focused is probably the better word. So they like to like stress things, but sometimes I feel like they've kind of lost sight of like what is the point. And the point is to have people make the right decisions for what they're going to be doing. And so like looking at CPU rendering, like yeah, cool, it's a cool benchmark, but it's for most people it's essentially a synthetic benchmark.
Mhm.
Yeah.
Yeah, most people in the 3D space that using this class of CPU are going to be doing GPU rendering, because that is a 4090 would be like 6 times the rendering speed of 14900. So like
Wow.
there's, unless you're like running out of VRAM, which would be 24 gigs, like there's no reason to be doing CPU for Blender. Like it just doesn't make sense. But yeah, you'd go Threadripper because you need the VRAM, need the system RAM, or
Mhm.
just do GPU.
Yeah. Yeah. Well, plus I feel like it's almost cheaper to go GPU.
Yeah.
Really, because
Yeah,
like you start getting
unless
into those real high end multi-core CPUs, you're talking 1200 plus. I mean, at one point you break into that, it's about equal, but then anything above that, you're throwing out tons of money.
right.
I mean,
Yeah,
even
the
at the
only
low
people
end, like
sticking on the only people sticking on CPU for rendering that like have to that is because they're using an engine like um there's one from Chaos, I can't remember right now, not V-Ray, but the different one that is only CPU rendering. It's mainly like architects and that kind of stuff.
Okay.
In that case, these are professionals. They're going to want something that is going to save them a lot of time, so they're going to go Threadripper.
yeah,
Okay.
or they're going to be in a server because they're doing like a server farm type of situation,
Mhm.
offloading kind of situation, and that's just not the same people
Yeah.
here. I mean, we've talked about at some point like, hey, for like 14th gen or Ryzen, should we even include CPU rendering benchmarks? It's kind of like, so I think we've kind of arrived at, and Kelly, correct me if I'm wrong because this is more your space than mine, but we've kind of arrived at the like, you know, as long as we're clear that this is more of a synthetic, like worst case scenario kind of situation for these kind of CPUs, like yeah, you can't hit this, but it's really for people who are doing like programming and they're doing code compiling. Like this is kind of an analog until we have a benchmark really for that. That doesn't take a lot of manual work from us,
Yeah.
and things like that. It's like we kind of treat it as a synthetic in that case. It's a representative workload. It's not really for people that are going to be using, you know, Cinema 40 and using the CPU renderer, or the people who are going to be doing
Right.
CPU rendering in Blender. Like, just don't really exist.
Exactly.
I think that's a good intro to all of this. We covered some good topics on the front, so I guess let's dive into some of the details, some of the more in-depth look at what we've found out this go around.
Sure, sure, yeah,
Yeah. We'll work down the article because I think it starts with like Photoshop and stuff.
yeah, sure.
So we'll
Yeah,
go
you
from
want to
there.
switch over to my screen?
Yeah, we'll go.
All right. So yeah, if anyone wants to look at these articles, yeah, I'm sure Houston will put something in the chat. Because yeah, we have information on like MSRP costs, which MSRP costs are rough. Intel tends to be pretty stable, but AMD do regular sales,
Right.
and so like their cost is up and down. It totally depends on what's going on. Um, Lots of info in there, but yeah, we'll just jump straight down. I think yeah, we actually started off with Lightroom Classic here, and on all of these, there is at the bottom a full performance analysis link, because this is basically just like one or two charts that's like combined of everything. So like if you just want to look at the charts, this is great. But if you actually want to get into like detailed analysis more than just a couple paragraphs, make sure you do head over to those articles because we talk a lot more about gen over gen performance and AMD versus Intel and things like that. But to start with Lightroom Classic, I mean, top end, I mean, you can see basically 13900K is the top blue bar here. And then, can you see my cursor? Yeah, you can. And then the 14.7 and 14.9 are actually almost identical in performance, and it's like margin of error faster. So if you're looking for like the fastest system for Lightroom Classic and this class of CPU, it's basically no different than previous generation. If you're already in the market for a new workstation, like the 14.7 is actually really nice to. Can I zoom in more? No, I can't really. The 14.7 is a really nice CPU because you can like get pretty much the same bang for a lower buck. So if you're already in the market for a new system, the 14.7 I think is basically an ideal CPU. You can save a little bit of money, get the same performance. Cool. And versus Intel or versus AMD, yeah, it's a performance increase. It's not a massive difference. It's like 5% or something like that. So it's basically you can go either way. If you're looking for the top performance, 14th gen. If you like AMD, cool, go AMD. It's not really going to hurt you a massive amount. Except at the low end. If you're on a quick budget, like 7600X is at the bottom, 14600K is up there. Yeah, that's a bit more of a performance jump. Photoshop, basically the same thing. 14.7 doesn't do quite as good. Photoshop's a little bit lighter threaded than Lightroom Classic. So, but it's basically 14th, 13th gen. You're talking a few percent. What was the difference? 1 to 4%. Margin of error, basically. It's consistently is higher. So, yeah, there's a performance there, but margin of error. So, cool. We don't need to keep talking about that.
Yeah.
Premiere Pro, basically same thing. Margin of error differences. The 900s, basically the same thing. The 700s, basically the same thing. 600s, basically the same thing. This one's even closer. So like Premiere Pro, cool. I think we just do blind subs on our orders, and no one would even know if it was 13 or 14th gen.
Jeez.
Because even like Premiere Pro, we do get into things like Intel QuickSync. That's one of the reasons why Intel is like most of the top spots, and then AMD is at the bottom, is because Intel has QuickSync, which can be used for hardware decoding of H64 and HEVC. But 14th gen doesn't have anything new compared to 13th gen, so it's the same thing.
All right.
After Effects, a little bit more performance out of 14th gen than 13th gen compared to like Premiere Pro, but yeah, again, you're still talking like 5%. And then it's like it's a broken record for most of my stuff, like the media and entertainment world. Yeah, you're talking as small of a difference as 1%, as large of a difference as like 5%, and that's basically it. Resolve, same thing. Broken record. This is one of the most like boring launches I think for like my area of expertise that I can like ever remember. I don't. Maybe there was. What was the CPU going from like the 4790K to like the 5790 or something like that? I think it was similar to this, but it's been a while since we had something this minimal. That's all my stuff. Kelly?
Easy enough.
All right. If you just keep your screen up.
Sure.
So, yeah, Unreal Engine 14.9 versus 13.9 is, I mean, was it 10 points different? So that's like 1%.
Oh, man.
Really no difference there. The 14.7 had a reasonable increase over the 13.7. I think that one was, I wrote it down, 10%. So that's respectable. But then the 14.6 and 13.6, again, identical scores. So really no difference there. Yeah, like for compiling shaders specifically, either of the top three CPUs, the 7950X, the 13900, 14900, they're all the same. So just go with whichever one has the best deal at the time, and you'll be set. For compiling source code, it's basically the same thing for Unreal. For as far as performance differences, I did not include light baking on this article because the scores were unusual,
Right.
but the like very inconsistent timings, like 25% difference from run to run. So I just got rid of them because I didn't trust them. But on average, the 14.9, 13.9, 13.7, 14.7, 7950X, and 7900X were all averaged the exact same. So whatever your budget is, just go with that for this class of CPU. Down to rendering, like we were saying before, this is not the CPU you're going to buy for rendering, for CPU rendering. But if you did need to use it, the 14.9 is, what was it, like 4%, 5% faster than the 13.9?
Mhm.
Yeah, not
Until at the
much.
top.
Yeah, I mean, this is the first time we've seen Intel outdo AMD for CPU rendering in this class for a long time.
Wow.
So even though it's by like 2%, they still did technically take the lead. Of course, this is for Cinebench, which is Redshift CPU. So if you're using Cinema 4D, Redshift is now the default renderer for CPU and GPU, but you'd probably be using GPU unless, I don't know why you would use CPU. I guess the only reason you'd use CPU is if you don't buy the Redshift license, then you would default to CPU rendering. Is the only reason you would ever do that. So just buy the license and then you'll have faster renders on your GPU anyways. Down to V-Ray. This is more traditional of what you would see for CPU rendering. I don't know why Intel does so good on Cinebench 2024. I'm like really good compared to V-Ray. But whatever. So yeah, the 14.9, 13.9, same score. 14.7, 13.7. You see a 10% increase, and 14.6 and 13.6 are identical. And then going down to Blender, it's the exact same chart as V-Ray. Yeah, it's just no different, no other story to tell really. Like it's the same CPU for these workloads.
That's pretty much, yeah, that's everything.
Yeah. I mean,
yeah, so this is one of those ones, man. Like, I'm looking forward to doing one of these live streams when the new Threadripper and Threadripper Pros come out, because that will be a lot more interesting of a stream, I think, than this 14th gen.
Yeah.
But,
well, I think this is, from all the like rumors I'm reading online, this is the last Intel CPU on this chipset or on the socket or something like that. And then,
oh man, we're getting another one again.
Yeah, once they go to a new socket, new everything, that's when we'll probably see an actual bump. But this is just a small refresh.
Because this one is unusual too, because we have 3 generations of CPUs that work on the same platforms. 12th gen, 13th gen, and now 14th gen can all be on the same boards. Like you can use Z690 for all 3. Usually it's just been 2 generations from Intel. You get the TikTok or that's what they used to call it. I don't think they call it that anymore. But you'd get like the 2, the new socket, the refresh, and the new socket refresh. This time we're getting 3. So it's a little bit weird. It must just be that they're getting better yields on their wafers than they like either expected or maybe they're having to, because 15th gen, whatever they wanted to do is taking a little bit more work than they expected. I don't know. We have no idea why Intel would launch this 14th gen, but it's probably something along one of those 2 lines. So yeah, it's a 13.5 gen really.
Yeah. We do have a question from the chat. It's a previous gen question, but I think it's still a little relevant considering these CPUs are basically equal. Alok here asks, where does the 13.5 rank versus the 7600 if they're priced exactly the same? And I asked a follow-up about workflow and software, and they asked in the context of video editing and learning CUDA with a 4070.
Oh man, I don't even know anything about that CPU. We pretty much test only down to the like 13600K is as far down as we test. I can tell you though that
should be fairly close though. I think if we look at the 13.6,
we do. It should be close. You can also look at in our benchmark database.
Oh, that's right. Yeah.
Yeah. Here, you want to switch to my screen?
Sure. We'll go to
show
this. I think this.
So if you go to benchmarks.futuresystems.com, you can search through. This is all of the public uploads into our database. It's a very rudimentary, system right now. We have it's on our to-do list to make this much better. But you can search for 13500 and then do like Premiere Pro, video editing. There you go. So it looks like scores for that. Now this is all from the public, so we have no idea if they're overclocking, no idea if they're thermally throttled or whatever. But it looks like scores are somewhere in the 8 to 900 range. 7600 for the same thing. Looks like they're in the 5 to 8. There's a lot more variance here.
Yeah.
Well, some of it, like that's
Some of those might be laptops or
right.
something.
Yeah, I'm not sure why this is coming up with. Oh, because there's a 7600S.
Or yeah.
Yeah, I need to add in a space.
It looks like they have the same number of P and E cores. They're just the 13.6 is clocked a little bit faster.
Okay.
So pull a few percent off. It sure looks like they are very, very similar. It looks like maybe the 13500K has a bit of a gain. 13500K is probably also a bit better if you're doing video editing, because then you can utilize QuickSync. So just make sure the integrated graphics is enabled, because you can kind of see here, like these ones are only getting these top two are only getting a score of around 800, and you'll notice there's no Intel UHD graphics under the video card, so they disabled their onboard graphics, which turns off QuickSync. These two have, well, no, this one doesn't. This one's probably an overclocked one, but this one does have it on, and they're getting, a full 100 points higher, and that's because of those tests that you can utilize QuickSync. So between those two, I would probably definitely say it's the 13500, as long as you're doing anything with H.264 or HEVC media, which at your budget level you probably are. So I'd go that way.
And that's another thing we didn't really touch on with integrated graphics for this generation. It's the exact same iGPU as the 13900. So that didn't even get an upgrade either.
Oh,
so
weird. Yeah.
Whatever performance you got from that before, it's the exact same on this.
Yeah. I do remember with the new CEO that Intel has, that I thought I remember reading that they were going back to the TikTok pattern, I guess. So this would be the talk, right? Before we get because there was mention about a new socket, new platform coming, and all that. So
Talk Plus,
or yeah, because it should be like TikTok talk, right? Yeah,
yeah.
But it seems like this has just gone so fast. You said three CPUs basically on the same platform, and I'm like thinking about it. I'm like, yeah, holy cow, that's right. But it seems like it's gone so fast. Like, I don't know. It doesn't feel like it's been 3 CPU generations.
Yeah. Well, and also too, think of like if anything a CEO says, it's going to take 4 or 5 years before whatever new direction they want to do. Because they have stuff planned out for multiple generations, I'm sure, by Intel. And from what I understand, it's even different teams. So the people who are designing 13th gen are a different team than the people designing 14th gen, because it takes so many years to do stuff that you can't just do cool, we launched 13th gen, now let's start on 14th gen. No, 14th gen was started years ago.
Right.
You can't just do it iterative. So it has to be weird leapfroggy kind of things. They make the general architecture stuff, and then the 13th gen team starts doing stuff, while at the same time the 14th gen team is pushing things further. It's weird and complicated, so yeah, it takes time to make any sort of those changes.
In a future episode, I would love to get somebody on who knows an expert in lithography, because I stumbled this totally aside where I think we're a little finished with our result talk, but I just recently saw I think it was a Twitter thread with somebody who used to work for Intel on their lithography team, and the math involved, they were showing a picture of what the light beam, the shape of it and stuff, that it comes, the laser that comes out or whatever it is, and as the technology has improved, it gets fuzzier and fuzzier, and they start getting into quantum calculations and stuff. They have to guess kind of within a certain percentage of how the thing is actually going to come out right and stuff like that. And I'd love to dive more into how that works, because I know it'd go over my head, but man, it'd be super interesting.
Well, we're hitting how small we can make transistors, right? Like, what are we down to now? Like
Mhm.
10 nanometer or something, and the hard limit is like 6 or 4
That's
or something like that.
that's another thing that kind of blew my mind is when they're talking about these nanometer processes and stuff. That isn't the size of the transistors. I can't remember exactly how it works, but the basically yeah, the transistor size hasn't changed in quite a while because yeah, they're you get electrons jumping and weird quantum effects and stuff like you were getting so small. So the process I think has more to do with the lithography part, the tightness of the beam or something. I don't know. It's way beyond my understanding. Um, yeah, 1 nanometer as long as you redefine a nanometer. Yeah. But yeah, that I think would be a fascinating dive into just to know a little bit more about how these things work and the because like I think everybody kind of understands that like the the binning process, right? Like the big wafer that gets etched out and stuff. The good stuff is toward the middle, and then the as you get closer and closer to the edges, those are your more lower end processors and things like that. But to get a little more into the actual like physical aspect of lithography, I think would be really interesting.
Yeah, and I also wonder how close we are to CPU gen over gen performance gains being single digit. I mean, it feels like we're starting to get there, but we still have every once in a while. Like 12th gen was a big performance bump when we moved to P&E cores. Ryzen 7000 was a big performance bump from AMD.
Yeah.
But I wonder how soon we'll be there because even like the new Threadrippers and Threadripper Pros that AMD announced, I have no idea how much faster there's going to be, but there's only so much you can do about like just cramming more cores in, because most of the heavily threaded stuff, software developers are moving that stuff onto the GPU because GPUs are so much better at that kind of stuff. Like,
Right.
hey, why run it on 64 cores when you can run it on thousands of cores?
Yeah.
So even like the higher core counts, like I'm really interested to see because what was the highest that AMD announced? Um, I want to make sure.
I saw something about 96, but I don't know that that was the
I think it
highest.
was 96. Yeah, I'm pretty sure it was 96 cores. Yeah, 96 cores is the highest. But even that, like, I'm really curious to see what kind of workflows that'll be good for. Like, yeah, there'll be some stuff like CPU rendering, software code compile will probably actually be like one of the biggest use cases we end up using for it. But beyond that, like, you're not even talking multitasking anymore. Like,
Right.
multitasking for most things, like, yeah, maybe 64 cores, but even then, like 32 oftentimes will get you plenty of what you need. So, like, man, how niche of a CPU is that 96 core going to be? I have no idea. So, but, and, same thing on like, frequency. Like, I wonder how far can we even keep pushing this stuff? And at what point are they going to have to re
Right.
examine and just say, like, forget all of these E cores, forget all of these, single, how Threadripper works. Like, we're just going to go back to the days of quad core. And it's just like, here's as fast of a quad core CPU as we can make because everything that's going to use more than that is going to be on GPU. Now, that's an
Right.
exaggeration. I think like
Yeah.
8, 10, 12 cores will probably actually be the right balance. But still, like, at what point do they just like forget everything else? We're just going to make as fast of a CPU as we can because everything else will go somewhere else.
Well, I'm seeing too. Nvidia and AMD both are starting to get into the ARM
Mm-hmm.
processor thing, and so I'm curious how that's going to work and how because I understand how that I have a basic understanding of how that works with like mobile devices and things like that. But if we're going to start seeing a shift to ARM based like regular desktops and stuff, that's like a whole software shift and everything. Like the very core of it all kind of changes a little
Yeah.
bit, and I wonder how that'll work.
I mean, there's a
Well,
decent number
also,
of workflows even today that like the whole rest of the system is really just a platform for the GPU, like GPU rendering, AI, a lot of AI stuff. Like it's just a platform, and like if you could replace that with an ARM platform that's just like integrated into the graphics card, then it's like cool. Give me like a power socket and give me a monitor output and like a couple of USB ports, and now like or not even USB ports, just like it goes into a server room, and like that would be amazing.
yeah, I mean, I think that's going to be the big shift. Is we're already saying like PCIe lanes getting faster, but
Hmm.
just a
Hmm.
better interconnect between CPU and GPU which I think is what NVIDIA is going to try to do, is make a platform where those two things are basically next to each other and can just crunch back and forth. Because right now, if you run out of VRAM and you have to go to system memory, you have to go through the PCIe bus to the CPU to the system RAM, back through that whole thing, back and forth. But if you could tightly integrate that entire process, like you can open up just a better ecosystem for everything. That you could use the CPU as needed, GPU as needed, whatever. But it needs that whole platform to work better.
Right. There is a question here from Orest. ZBrush's CPU powered software. Have you tested it?
No, that would probably be my wheelhouse if we started doing that. It's one of the many things I want to test. But yeah, it's CPU based, pretty much a few cores. It's surprising that it's CPU based since it's dealing with millions and millions of triangles. Like you would think it'd be a GPU based system, but it's
right
CPU based. They just have an extremely smart way of handling the system. But yeah, it's all CPU based, but we haven't tested it yet. That's on our to-do list. We do have recommended systems based off of what Maxon has informed us that would work best for that. So, but we don't have any testing on it.
It's pretty lightly threaded, right? So it probably results would be pretty similar to our Photoshop results. My impression is it's kind of similar in terms of like CPU load. So it's probably going to be one of those things where Intel has a very slight lead, but not much of one, and like the difference between like a 14700 and a 14900 is minimal.
Yeah, you would want to look at or Cinebench single core. That might give you a good idea.
Okay. I like this. There's another follow-up from iLock. Let's skip some of the intro part of this, but what about they're talking about an A380 on an AMD platform? Does that make sense just for the AV1, or should you go strictly with just the Intel Core?
You can do it. So one of the things we want to experiment with more with the next generation of Intel Arc cards, so Battlemage, is using them as essentially an accelerator card.
Sure.
So because most of those Intel Arc cards don't really have a lot of oomph as far as like raw GPU power. Like they're even the A780 is equivalent to like a 3060 or 3060 Ti. So well under what we target as a system integrator. But I mean, if it works for you, cool. But so we're interested in doing it as a secondary card because then you can get like the AV1 encoding, you can get the improved HEVC decoding and encoding, and we can put that on an AMD platform. We can put that on Ryzen. We can put that on Threadripper Pro is the one where I'm most excited because then like you can have a best of all worlds. You can have a Threadripper Pro system that's really good at working with raw footage, and then you can have the Intel Arc card as an accelerator that can handle all the HEVC and AV1 stuff. That'd be awesome. But as far as like using it with AMD versus Intel, it shouldn't really matter as your base platform. Using an Intel platform that has an iGPU as well does give you some benefits. Resolve has, what do they call it? Deep Link or something like that. So it'll use the integrated graphics and the Intel Arc card, the decoding whatever. It's not called QuickSync. We even asked them like, hey, what is this called on Arc? Is this QuickSync still? And they said, oh, we don't have a name for it. It's just
okay.
Hardware decoding and encoding on Arc. But you can use those in combination, and especially if you like really set it, you can do like, hey, I want to use the iGPU QuickSync for decoding because it's slightly faster for that, and then use the Arc card for encoding, so you're not like trying to do both on either device. That usually works really well. As far as like how much performance that gets you, that usually nets you like an extra 10-15% performance. So like, yeah, in those special situations, cool. If your raw footage is like ProRes and you're just encoding to AV1, like it really doesn't matter because you're only doing one hardware based thing at a time. So in that case, yeah, I can go onto either platform. But all things being equal, I would probably put it on an Intel platform. There's less brand mixing of drivers, especially if you have like AMD with integrated graphics and an Intel GPU. Like the less mixing of GPU drivers, I think better. Intel drivers, I think, are pretty good at playing with others because, like, we've had Intel integrated graphics that have, people have put AMD GPUs, NVIDIA GPUs for years and years. But AMD drivers, I don't know if they're quite there yet for that. And then at the same time, too, I see another question also about like using it as a secondary. I'm also not sure about Intel drivers for the discrete cards being really good there. So I know at launch, like I think Linus Tech Tips did a video on it, and like they had massive problems trying to do that. We played around with it a little bit, and it was okay. But kind of our thought is we're gonna wait for second gen before like selling systems to professionals, where like a blue screen can cost thousands of dollars and that kind of stuff.
I mean, what Intel should really do is look into making these as a encode decode add-in card as opposed to a graphics card, and just be able to have that set up as a device. Because like I think Red did that for a while, or maybe they still do.
Yeah,
the Red Rockets.
Yeah,
right?
they have the
Yeah,
the Rocket X. Yeah. Those are still exist, and some people still sell them. But like a GPU from NVIDIA like outperforms it because now they have GPU debayering and decoding. So like it's a stupid product, but it still exists. But yeah, I totally agree. But at the same time, like what would the difference be? They take off the video outputs, like.
I want Intel to still stay in graphics cards, though. I think it's a good. I think it's a good to have a little extra competition in the kind of lower to upper mid range for the general consumer wedge of the price to performance B curve, right? I think we've had spent too many years as a community of enthusiasts, at least, pushing too much on the high end, where like, oh, you don't have a 1080 Ti or 3090 Ti uber duber, then you suck kind of stuff. And I think it'd be nice to have more conversation around like, hey man, this is great. Like 1440p at 60 FPS or whatever is fine. It's great. In fact, we don't all have to keep pushing for $4,000 high end graphics cards and stuff like that.
Right.
Well, the hard thing with us is like any part we carry adds complexity for everything, so we have to pick and choose. But yeah, for the general market, I totally agree.
Yeah.
And one of the things with Intel too, with the art cards, heck, even want to switch to my screen. We did recently a revisit on art
because
we had launch day content and so we did a revisit. I believe it's a 10-month. I think it's been 10 months since launch or something like that when we did this article. And so the ARC A770, this is just one of them. Like that's up here right now. It's getting a resolve like a score of over 2200. If we use the old driver, so this is with even modern software, we're just, hey, let's look at launch day drivers. It got like a 25% performance boost in the awesome. 10 months or whatever. So Intel is doing a lot right now. They're doing a lot of things right on the GPU side. I'm sure they still have work to do, but that's again one of the reasons I'm excited for Battlemage, because like this is all just software improvements. Right. What is it going to be once they also have all the hardware side, updated to the next generation?
Yeah.
And we're getting very off topic from 14.
Yeah, no, I think we don't need to push this for a full hour. I think we've covered everything we needed to cover, and so I don't need to take any extra time away from you guys. I know there's things on the horizon for you all to be working on. So I think we'll just call it here. We're a good 45 minutes or so. So thanks to you guys. Thanks to the audience for joining us. And this was super surprise. Hey, we're back kind of thing. So I appreciate everybody who did show up today, especially you two. Thank you guys very much. Anything else you guys want to say or shout out or before we go?
Well, let's do this again on all these major launches. I like
that's right. These. Actually, we do have another one coming up. Tentatively, I want to make sure I get this right. Yeah, tentatively the 21st of November. That is a Tuesday. That's the Threadripper 7000 new Threadripper stuff. That I think is, well, that's what I have on the calendar for right now. So, stay tuned for that. Thanks everybody for being here and everything. We'll see you all next time.